Environmental Protection Agency conducted a test for PCP, a cancer-causing agent, in rivers and lakes across the nation. Of the sites tested, 91% tested positive for the presence of PCP. After implementing a water cleanup program, a follow-up test for PCP was conducted, where 160 out of 200 test sites tested positive. Test the claim that the water cleanup program reduced the proportion of water sites that tested positive at a 1% level of significance. So, the null hypothesis is that the proportion is equal to 91%, 0.91. The alternative is that the proportion is less than 0.91, in other words, that the water cleanup program worked. So we have a level of significance equal to 0.01, and to test the hypothesis we have to verify that NP and NQ are both bigger than or equal to 5, so we can use the normal model. So N was 200 multiplied by P 0.91 gives us 182, and 200 times the complement of 0.91, 0.09, is 18. Since both of these guys are bigger than or equal to 5, P hat is approximately normal. So let's draw our normal curve for P hat. And we're assuming 0.91 is going to be the mean for P, so it's the mean for P hat. And where do we find our P hat? Well, our P hat is equal to 160 out of 200, and dividing that out on my calculator gives me 0.80. So, again, right away, you might say, well, yeah, the cleanup program did reduce the number of sites that tested positive, but did it do so at a 1% level of significance? In other words, based on the original number being 91%, is the likelihood of getting a sample with proportion 80% sites that tested positive less probable than 1%? If the answer is yes, we reject the null hypothesis and in favor of the alternative that it did work. And if the probability of this occurring is bigger than 1%, then we don't reject the null hypothesis and say the program didn't work. So let's transfer this into probability. So we have a one-tailed test, and so the p-value is going to be equal to the probability that p hat is less than or equal to 0.80. And again, we're ignoring continuity correction here because 0.5 divided by the sample size n is significantly small. So we'll just transfer this into z's and get z is less than or equal to 0.80 minus 0.91 divided by standard deviation, which is square root PQ 0.91 0.09 divided by n 200. And this is equal to the probability that z is less than or equal to, and let's jump to our calculator now. 0.8 minus 0.91 divided by square root of 0.91 times 0.09 divided by 200. And I get a z-value of minus 5.44. And by now, at this point, you probably recognize that a z-value of minus 5.44 has a probability of 0, because on the z table it only goes to negative 3.44. and anything smaller than that has a probability of essentially 0. Wow. So what does that tell us? Since the p-value, since our p-value is less than a level of significance alpha, we reject H0, the null hypothesis, in favor of the alternative. And what is that alternative? That the proportion is less than 0.91. So this is exactly how they do it out in real life. This proves, at a 1% level of significance, there is sufficient evidence to say that the program did work.